Hi and welcome back. So in the past video we were doing this example of trying to figure out, based on maybe some data that Millikan could have gotten out of his oil drop experiment, what the charge would be on one electron. If we did 5 different trials, and we know that Millikan did probably many more trials than 5 trials in order to figure this out, and probably he also had much bigger charges than the ones that we have here, because we're only going to have a few electrons in these charges actually. But we took the ratios of all of the charges to what we guessed, our first guess at what the charge of one electron was, and we guessed our first guess was going to be this. It was going to be it's actually not. It's going to be our charge of the least magnitude, which was minus 9.6 times 10 to the minus 19 coulombs. And we found out that the ratios that we got, only one ratio that we took gave us a whole number, and that's what we need. That's what we're looking for to figure out the charge of one electron. Because once we find the charge of one electron, we're able to say, look, all of these other charges have got to be whole number multiples of that charge of one electron. So we took the ratio, and we found out that we only had one charge that was like that, where we had a whole number. But look at all these other ratios. What's the common denominator that we have for all of these other ratios? Well, it's 6, right? And we could even rewrite this whole number. We could even rewrite that as 12 over 6, right? That's the same thing as 2. So now we've got all of our ratios expressed as having a common denominator of 6. So what if the charge of one electron actually was 1/6 of this charge? What if it was 1/6 of our first guess? What would that be? So now, and you can probably see where this is going, it would be if we multiplied each of these ratios by 6, which would be the same thing as if we divided by 1/6. So it's the same thing as taking, let's just take this example where we had 36.8, this charge of the largest magnitude. So we said 36.8 over 9.6 divided by 6. So that's what we're going to find out now. And let's just go ahead and figure out what that would be. And that would be the same thing as multiplying this whole expression times 6, right? So let me go ahead and get my calculator out. So we had, let's actually just figure out what 9.6 divided by 6 would be. And it would be 1.6. Okay, so now let's divide 36.8. So 36.8 divided by 1.6. And there we go. We've got our whole number answer. So 36, if we now say our new guess for what an electron would be, is 1/6 of our first guess. So we're going to say so our second guess, actually, you know what, let me go over here a little bit. So our second guess for the charge of one electron is going to be minus 9.6 times 10 to the minus 19 coulombs divided by 6. And we figured that out just 1 second ago, oh, that's not what I wanted. There we go. That was going to be, so we say 9.6 divided by 6, and that's going to be 1.6. So we can say that our second guess for the charge of an electron, and it's not coincidence that this actually is the charge of one electron. I did kind of prepare this problem ahead of time, that it's going to be minus 1.6 times 10 to the minus 19 coulombs. And now we can hopefully see what would all of our ratios be. because it would be the same thing as multiplying all of these ratios by 6, right? So now let's actually, you know what, let's just go ahead and redo the ratios, because there is infinite time to do examples on YouTube. So I'll just go ahead and I'll erase that, and I'm going to redo all of our ratios with the new guess. So let's say, so our new guess is that the charge of an electron is minus 1.6 times 10 to the minus 19. See? So let's figure out how many electrons would have been in this drop of 11.2. So let's say that we have, and we'll just leave off all the extra times 10 to the minus 19, C and everything. Let's just figure out what 11.2 divided by 1.6 will be. And that is going to be, so clear 11.2 divided by 1.6. And there we get a whole number. We get 7. So this is going to be 7. Now let's actually take the ratio of our first guess, because now we see that this drop isn't just going to have one electron in it, and you can probably already predict what this is going to be, because we found this new guess by dividing this by 6. So we can even, actually, you know what, I don't even need to get the calculator. 9.6 divided by 1.6, and we figured out, and the way we got to this second guess was that we divided 9.6 by 6. So that means that this drop, this yellow drop, would have had 6 electrons in it. And then let's do this drop, this 19.2 drop. So 19.2 divided by our second guess, divided by 1.6. And there's our calculator. So 19.2 divided by 1.6. And that gives us 12. So this drop would have had 12 electrons in it. And then we've got our 30.4. So now 30.4 divided by 1.6. And that is going to equal 30.4 divided by 1.6. That's going to be 19. So this drop, again, had a whole number of electrons, and that this charge is a whole number multiple of 1.6. And then finally, let's do our last magnitude, our greatest magnitude, which is 36.8 divided by 1.6. And what is that going to give us? So 36.8 divided by 1.6. And that gives us 23. So another whole number. So that is going to be 23. So therefore, all of these different charges that we measured, all of these different charges are whole number multiples of what we have found to be the charge of one electron, which is minus, I'll write it down one more time. I'll write it down up here. So the charge of one electron, we have found it to be minus 1.6 times 10 to the minus 19 coulombs. And that actually is the charge of one electron. So anyway, we'll do more problems with this probably in the future in this playlist. But for right now, that was just a little bit of a few videos on Millikan's oil drop experiment, and I guess how it was done. So anyway, thanks so much for watching, and I'll see you in a future video.